Hello everyone. In this lecture we just want to briefly discuss the transformations involved with logarithmic functions. So I'm going to consider the logarithmic function log of x to the base b, and we wonder what's going to happen if we have log of x minus 4 with the same base of b. Now we can choose the base to be like 10 or like any other base. I will just leave it as 10, so I'll use common logarithm here. So how would this graph look like? We know the graph of logarithmic function. So it is like this green graph, as you see. We know the domain, we know the range and all of that. But what would be the graph of this function? Well, I think you remember that we have talked about functions of the form f of x if they undergo transformations and they become f at k times x minus d plus c. We have discussed that the d is representing a horizontal shift either to the right or to the left depending on the value of d, depending on the sign of d. So here we see that instead of log of x we have log of x minus 4. So we say that in this case we have a horizontal shift or translation to the right by 4 units. So to the right by 4 units. This is the name of the transformation involved, and the graph is going to horizontally shift to the right, and when it shifts to the right, the vertical asymptote also shifts with it. It's not like the vertical asymptote stays where it is and then the graph by itself just shifts to the right. It's not like that. So the graph is going to look like something like this: 1, 2, 3, 4, 5, 6. So this is 2. So we have our vertical asymptote this time at x equals 4. Okay. And in fact, x equals 4 is the equation of the vertical asymptote this time. But in the past, it was x equals 0, if you remember. And the graph, instead of having an x-intercept of 1, now it's going to have an x-intercept of 5, actually. And the graph is going to look like this. So this is how the graph looks like. A sketch of it, of course. Y equals log base 10 of x minus 4. So that's how the graph looks like. It's a horizontal shift to the right by 4 units. Now, if it was x plus 4, same thing would happen, and the graph would shift to the left by 4 units. What else can I add? Now, this horizontal shift affects the domain of the function, obviously. So we're going to say domain of this function is the set of real numbers such that, now you see that before we said x has to be positive, but now we're saying that x has to be greater than 4 actually, because x cannot be less than 4. There is no graph on the left-hand side of the vertical asymptote. So here we're going to say x is greater than 4, but not equal to 4. That's the domain. Now, what is the range of this function? The range is going to be the same as it was before. Y belongs to the set of real numbers. So this is just one example about transformations involved with logarithmic function, which is not something new. We had this for like any function f of x in the past. Another example could be, for example, y equals, for example, we can have negative log of x plus 3, and then we can have a plus 4, okay? So the role of this negative sign in front of the function is creating a reflection in the x-axis. So the graph of log x is going to be reflected in the x-axis, so it's going to look like something like this most likely. So it would be something like this, of course, the dashed line you see. And x plus 3 would create a horizontal shift to the left by 3 units, and the plus 4 is a vertical shift up 4 units. So I wonder how we can draw a sketch of this scenario. So why don't we start by graphing negative log x, okay? So y equals negative log x is going to be a graph like this, and the x-intercept is still the same number, 1. And this is negative log x, and then we're going to horizontally shift this to the left by 3 units because of horizontal translation to the left by 3 units. So 1, 2, 3. The vertical asymptote becomes x equals negative 3. I draw it, and now I have to shift this graph to the left by 3 units. So it's going, the point whose x-coordinate is 1. Now, if you shift it 3 degrees to the left, it becomes -2, actually, right? So this is how the graph is going to look like. It's going to be something like this. So the first one was negative log x. The second one is negative log of x plus 3. And now we have plus 4. So the third one would be log of x plus 3, and then the whole thing plus 4, which means that every single point on the green graph should vertically shift up or translate up by 4 units. So this point here, which is actually -2, 0, it's going to go up. It's going to become -2, 4 actually. So 1, 2, 3, 4. This is where it's going to go. So this point, the x-intercept at -2, 0 is going to vertically shift up 4 units. So now it becomes -2, 4 basically. -2, 4 is the x and y coordinates of that point. And similarly, every other point on the curve is going to be vertically shifting up by 4 units. And the graph is going to look like something like this. So I have to see how it's going to look like. Roughly something like this. This is a sketch, of course, but it shows that every single point is being shifted up by 4 units. Every point on the green graph you consider is going to be vertically shifting up 4 units. And I don't think it affects the vertical asymptote. So for this function, I would say the domain is all real numbers that are greater than -3 but not equal to -3. And for the range, I would say the range is not affected, and still it is the set of real numbers because the graph is stretching from -infinity at the bottom all the way towards +infinity at the top. So this final one, the blue graph, is a sketch of what we had before. So that function, logarithmic function, has this graph. Whatever we have said in the past in terms of values of a, k, d, c, in terms of transformations of functions that we have worked with, absolute value function, square root function, reciprocal function, whatever we have said in the unit that we extensively discussed, transformations of functions, is still valid for logarithmic functions. There's no difference. Same rules, same everything, even same terminologies. Vertical stretch, if you just multiply by 2, for example, the graph will be vertically stretched by a factor of 2. If you multiply by 1/2 log x, that will be a vertical compression or a shrink by a factor of 1/2. So all the things we have said in the past are also true and valid for logarithmic function. There is no reason for anything to be different other than the shape of the specific shape of the logarithmic function that is discussed here. Other than that, everything else is the same as before. Thank you for your attention.